the permission to presentation.
Yeah,
Before that, I would like to introduce to the participants. Just 1 minute.
Sure, sir. Take your time, sir. No problem.
Yeah. Dear participants, going to listen the second session today up to 9 o'clock. So before starting of the session, I would like to introduce second session resource person. So sir is BIPUL KUMAR SHAHI. So is the Black Buck company, software company. So is a trainer and AI consultant, data science, data vision, visualization, ML, neural networks, NLP, generative and agentic AI, IoT, SWARPA. So SWAR is a vast experience in all these technologies. The career summary of SWAR is the seasoned professional with over 11 years of experience in cutting edge technologies, including data science, machine learning, deep learning, ML apps, and artificial intelligence, SQL, Tableau, Power BI, IoT, and blockchain. So skilled in generative AI with hands-on expertise in building and developing AI agents using Python, Longchain, Flies, and Render. So sorry, then OpenAI. So deeply involved in curriculum development and deliver for AI technicians, programs especially tailored for instrumentation majors. The structured program spans 3 semesters and covers fundamental to advanced topics including Python programming for AI, data structures, machine learning, NLP, computer vision, cloud AI, deep learning, AI in practice, and a capstone project with a strong emphasis on hands-on training. So programming language skills, Python, embedded C, PySpark, R, Solidity. So various tools. So sorry, the vast experience in using the various tools and demonstrating the various tools. So is also having the hardware expertise, then conducting the workshops and trainings. So delivered over 10,000 hours of hands-on training on AI, ML, data science, and so many things are there. So sir is expertise in various technologies like neural language processing, computer vision, generative and agentic AI, DBMS, RDBMS, MySQL, so cloud computing and blockchain technologies. And sorry, almost done many projects for various industries. And so many tools, how to use the tools, especially generative AI tools and ML apps and dev apps, then artificial intelligence and data science. So these are the specialized areas of BIPUL, sir. So
yes, sir. Yes,
the
sir.
areas of specialization projects and all these are very, very important. My dear participants, please concentrate on the sessions. So these are the very, very useful for train our students projects, major projects and mini projects. We can assign these kind of topics to our students. The students can learn and do the projects. Sir done the many projects on AI, machine learning, deep learning, and data science projects. Many projects are there. Sir, this is the great profile, sir. This will help to our participants definitely. Thank you, sir, for your accepting my invitation to take the session in the ATAL-FDP online. You
Sure,
proceed,
sir.
sir.
My
You can
pleasure, sir.
proceed.
My pleasure. All
You
right.
can proceed.
Hi, everyone. Good evening. I hope you are doing great. Right. And long story short, I'm just a kind of a corporate trainer, right? And having an experience of almost 11 years and associated with a few good corporate organizations for delivering the trainings or skilling, Right now, my current project is going on in Synchron, Bangalore. So last month I was in Broadways, Hyderabad. So it's like, and before that, it's like multiple IT companies are there in which I used to visit for, skilling up their employees and all. Along with that, I also got a good opportunity to visit Kids Warangal. And there it was kind of almost 10 days I was there. So there also it was a good interaction with the faculties and it was a very nice time over there. So now let's have a discussion on this machine learning algorithm or how can we use machine learning for the intrusion detection systems, right? So let me give you an initial overview that what are we going to do. First of all, I'll just try to give you some understanding, explanation, what is intrusion detection and all, right? And thereafter, I'll also try to have a hands-on with you. So for the hands-on, this is a file that I have. So I'll try to do it, kind of practically line by line coding. But since we have a limited time, that's why I am sending this particular thing in advance with you, so that you can have this file with you even when I'm explaining it, right? So I'll put in the chat. Chat isn't. I can't access the chat. Okay. So in case if I can't access it, I'll just show you this particular. See. This is on my GitHub, right? So you can just go to this link and you can access it. I'll show you the link. So that, when I will work on the hands-on, it will be easier for you to work on that, right? So you can access this. All right. So let's try to understand this thing, which is called intrusion detection, right? So what is it? See, there used to be a lot of attacks that happens on the server, on the system and all. Okay. So these attacks need to be prevented so that we can secure your network, you can secure your data and all. Right. So we will just try to understand first the fundamental of it, like what is IDS. Then we'll try to understand how machine learning can be used. And then the pipeline implementation, like what should be the process for it. And then we'll just try to have some practical consideration and so and all. And then we'll have a hands-on. So if I have to understand what is intrusion detection, before that we need to understand what is intrusion, right? So, if you have a website, you have a network, you have a server, obviously there used to be attacks, okay? Because everyone wants data, right? To access the data, to access the information, or to access some confidential information, people used to attack so that the information, because nowadays information is what? Information is money. If you have the information on time, then you can easily make a lot of money, right? Sorry, team. I just got some call. Okay, so everyone wants the information. Information is what? Information is money. If you have the information before time, you can do a lot of things. That's why the intrusion happens. Now, intrusion detection system do what? It just keep monitoring your traffic. That how traffic is coming. Is it like suppose your network traffic is your website is getting suppose 100 visits per day. All of a sudden it get 500 visits, right? So that is what? That is anomaly, right? That means there must be something not good, right? So it system just keep monitoring the traffic in real time, right? So that if malicious activity is there, it can detect easily, right? And it just act as a kind of a security layer for your network, for your website or anything, right? So now to detect it, for detecting it, we can have a two mechanism. One is called signature based mechanism and other is called anomaly based detection. Anomaly, the example that I just had given, right? Signature based is what we here just try to match the known attack patterns. Okay, whatever the attack pattern that last, suppose 10 years, 20 years, whatever the attack happened, suppose I collected all the data of those attacks, right? Like for example, the file that I had shared with you, in this thing I had used a data. This is a data of attacks that happened in last few years. Okay, these are the information that are being stored, right? So it's like we had, suppose someone is storing all those informations. Okay, this is called signature based detection. That means whenever the attack happened, it's like monitoring. We are just monitoring our network, we are monitoring our server, we are monitoring our website, we are just kind of making a document or creating a log of different activity. Okay, creating a log of different activity that is happening on my network, on my website, right? And whenever there was an attack or whenever there was something which didn't goes well, we just mention that, okay, this is something which is not proper, right? So after that, we can use that data to train a machine learning model, and that machine learning model can easily detect the attack in advance. Whenever someone will try to attack, that machine learning model can detect, right? So it is saying what? It just matches known attack patterns, okay, against the observed activity, right? This is fast. This is having low false positive and high true positives. Obviously, I want high true positives. It is ineffective against novel or zero-day attack. That means a new kind of attack. Okay, if there is an attack which is absolute new, that never happens earlier, okay, or that kind of attack never happens earlier, so this may not be good in that case. And here we require a continuous signature update. Signature update means what? Data update, right? Next kind of detection is anomaly based. Anomaly based, like I told you, suppose you have a website, you have a network, you have a kind of a server, daily 100 people are visiting over there, all of a sudden you get 500 visits, right? So that is what anomaly, right? So it's like identifying over here something unusual, right? Like for example, you are on an average in a week you are doing a transaction of suppose 10,000 from your bank account. Okay, total 10,000 transactions, like amount of 10,000, that is the average amount, right? All of a sudden in a particular week there is a transaction of 50,000. That is an anomaly. So bank recognizes it. Okay, many bank used to call. Suppose I'm making my using my credit card, and on an average, suppose I'm just kind of making a transaction of 10,000. 10,000 is a huge amount. Let's say 1,000 rupees. Okay, average amount in a week, right? And all of a sudden I make an international payment, or I'm making a 5,000, 10,000 kind of more transaction. So bank identify it as a anomaly. So there are two ways we can detect the attack. First, using the known data, other by identifying the anomaly, right? So IDS placement strategy, these are the strategy that we follow. Network based NIDS, that is network intrusion detection system. So here we inspect the network traffic, right? We just monitor the traffic at the network boundary, detect the attack targeting the multiple host. Just keep monitoring it and identify when it is little unusual and try to detect it. Second is host based. Okay, we try to inspect the load, log, system calls, the request response, right? Kind of like resource overhead, right? So these kind of things we keep monitoring, and then we identify whether there is attack or not attack. Like over here you can see lot of parameter had been identified. Okay, so these are what? These are the parameters we are currently identifying based on network, from our network activity and from our host activity, right? Like total forward packets. This is what? Host activity. Okay. So different packet length, backward pack network and host is basically behaving. Okay, how many, like how different packets and other things are basically flowing through the network. What is the flow control? So we just try to protocol. We just try to keep monitoring it so that we can detect the attack. How this project will be done, I'll explain. Right now, machine learning for intrusion detection. We have two options. Okay, supervised and unsupervised. Right, what is supervised? Supervised is like when we know the attack, the type of attack. Like in this data it is supervised because this is a data in which for every events we know like what kind of attack happened, right? Like over here we know here is a benzene attack. Okay, these are the different attack that happened. Okay, benzene. So what is benzene over here? Let's see. I had written over here benzene. That means no attack. If it is mentioned benzene, that means it's a normal traffic. Botnet, that means botnet attack happened. Brute force, that means brute force attack happened. So here my data is having everything mentioned. We have 197,000 events when it was no attack. Okay, 1.9 million events when it was no attack. 172 events when it was a DOS attack. Okay, 128,000 when it was a DDoS attack. So when we have a data in which it is labeled, for every information it is already labeled, then it's a supervised learning. Right. Now you may be thinking from where I get this data, because I shared the code with you and I have not shared the data with you. So you can get the data from this Kaggle. Okay. Kaggle, you can get the data. Here it's a very nice data. I'll also share this thing with you. Just allow me for a minute. Okay. This is your data from, you can access it from the Kaggle itself. Okay. Very simple. So I first access the data, I'll explain it, right? So that is called supervised learning if the features as well as the label is mentioned. Unsupervised learning is something where only the features are mentioned. Okay, that means type of attack is not mentioned. Only what happened that is mentioned. So unsupervised learning is used to detect the anomaly, unusual behavior. Okay, unusual behavior. Some behavior we just kind of noticing down all the behavior if it is common, right? Then we say the things are going good. If it is something which is unusual, right? Like for example, let's say in this data, okay, let's say we have forward packet length, right? So if I will access it, see data, okay, let's say this particular column I'm accessing forward packet length, right? Okay, so it is showing error because I have to execute everything once again. Okay, so let me access this data column. I'll show you how anomaly detected. Okay, accessing it may take a bit of time. Okay, overall, it's kind of thing. It's a huge data, so it may take a time. Overall, the understanding is, let's say I have okay. Let's say I have an average forward packet. You know, here what I'm trying to do. I'm trying to access forward packet length. Okay, forward packet length. Right, forward packet length max. Right. So let's say average is suppose 25. Okay, average is suppose 25. Okay, a standard deviation is let's say 5. Okay, this is my average. Okay, a standard deviation is let's say, let me just write it like this. Suppose forward packet length, forward packet length is equal to, let's say, average. Average is equals to 25, right? And let's say the, standard deviation. Standard deviation for this thing, let's say, is equals to 5. It means what? It means I will find out a range of third standard deviation. So what is the range of third standard deviation? Lower fence will be equals to 25 minus 3 into 5. That will be equals to 15, that is 10. Okay. And then upper fence will be equals to 25 plus 3 into 5. That would be equals to it is 30 and 40, right? Okay. So if the average packet length is lesser than 10 or higher than 40, okay, then it is unusual. If it is lesser than 10, it's fine. Okay. But if it is more than 40, that means it is unusual. 45, 46, that means someone is trying to attack. So this is called anomaly detection. So unsupervised learning basically detect that particular thing. Okay. Here, this is something, let's say we have a dot mean value. This is average packet length. This is 250 over here. Okay. And what is a standard deviation? Let's see the standard deviation. It is 785. So 785 is the standard deviation we are getting. It is so it means that here, this particular thing can't be used to identify the unusual behavior because it is compared to mean, it is higher, right? So we can use some other factors. We can just check on other factors kind of thing. Okay, so I just took an example over here. Now, here we will use these kind of data. Okay, there are so many, this data I'm using. Okay, this data I'm using. You can use other data as well. There are a lot of, these are open source data through which you can make this thing understand, like how we can make a machine learning model. KDD cup NSL KDD, classic data set with label network connections, right? So if you take this thing, right, I'll just try to search about it. So you can see this is another data, right? KDD cup 199. This is used the third intentional knowledge discovery data mining. Okay, this is something different, huh? NSL KDD. Okay, so this is one of the data, right? So there are multiple data are there using which you can identify or train the model. This one I am using. This is UNSW. So diverse attack scenario in contemporary network environment. Okay, so you can just take the name of it. Just try to search about this data. I'll also try to use one of them for the hands-on part. Right. So feature engineering for IDS. What are the feature engineering required? That means if I have a data, what are the features? So we just try to find out something like duration, total bytes, what are the total packets? Okay, what are the packets per second, bytes per second? Okay, these information generally required for identifying the attack. Time window features are there. Connections per IP in last minute, unique destination, failed connection, traffic volume. Host-based feature is like how many failed login attempts are there. Okay, what are the process creation patterns, right? So these kind of information we capture as a data capturing process. We need these information to identify unusual behavior, right? So this is the pipeline that we follow. First, we go through the data collection, okay, where we capture network packets, right? Next, we go for the data cleaning and pre-processing. Next, we go for the feature extraction and encoding. That means if there is a non-numerical value, convert into numerical form. Next, we go for the model training and then deployment and monitoring. This is what we are going to do practically, right? This is some code example. So for this code example, it is some data is used, but obviously this is just an example. So we'll work on it. Okay, I'll show you in the hands-on. Now we have an anomaly detection for IDS. Anomaly detection, as I told you, here I can use some of the algorithm like isolation forest, one class support vector machine, auto encoders. These will do what? Or density based clustering. These will do what? this will identify something which is unusual from the given set of information. Something unusual, that means it must be a kind of attack, right? So these are the algorithm. One of the example, you can say autoencoder, that is there to identify the attack. This is the autoencoder example. Autoencoder is something which is an unsupervised learning process. Okay, in unsupervised learning, K means we use hierarchical clustering. We use isolation forest. Autoencoder is a neural network. Okay, neural network that we use in unsupervised learning. Autoencoder is a neural network that we use where in unsupervised learning, right? Now, how do we evaluate that how good my model is? So for evaluation, we use these things: precision, recall, F1 score, and AUC value. Okay, what is recall value? Recall value is accuracy. Okay, like the code file I had shared with you. If you go through the code file, at the end, when I evaluated the model, you can see precision and recall. Okay, what this mean? This means that category 0, okay, whatever the category 0 is representing, we have basically over here 5 kinds of attack I'm talking about. So category 0 is benzene. Okay, these are the category, right? So let me just copy this thing. So we have, these are the 5 category. So it is saying that benzene, that means normal condition. Out of total, condition which is normal, 99% is identified with a 99% accuracy. It is in with the 99% accuracy, it is identifying the normal condition. Okay, 100% DOS Hulk attack it identified. 97% DDoS attack it identified. Okay, and then 97% other attack it identified, and 91% DOS golden eye attack it identified. That is a recall value. Okay, what is precision value? It is saying that out of all the attack that is identified as a benzene, okay, 100% of them were correct. Okay, it may be confusing. Let me try to explain it like this. See, if I will have, let's say, here I will create a confusion matrix. Okay, so let's say here I have normal condition. Okay, that is no attack. Okay, this is no attack. This is what no attack, right? And this is what attack, right? Fine. So now let's say, and here this is what actual value. If I'm talking about no attack, that means this actually happened. Okay, let me just try to do it over here. Okay, this is what real condition in the data. That means from the data, this is a real no attack. This is a real attack. Okay, and here we have a predicted no attack and predicted attack. Right, predicted what? No attack. Predicted no attack. Oh, I can't place it. And here it is a predicted attack. Okay, now let me just write some random number over here. Right, so let's say I'm writing over here 300, or let's say 400. Okay. And here I'm writing 100. Okay, here I'm writing, let's say 50, and here I'm writing what? 450. All right, nice. So what will be the recall value? Recall value will be the normal accuracy. That means here recall of no attack will be equals to accuracy of no attack. That means how accurately we identified no attack. How accurately we identified no attack. That would be 400 divided by 400 plus 100. Okay. That would be equals to 80%. That means the accuracy with the 80% accuracy, I am identifying no attack. Okay. But here what is important? Identifying attack is important. Okay. Identifying attack is important. That means true positive is important. Right. So recall of attack. It means I am identifying over here 450 attacks out of total 500 attacks. Out of total 500 attacks, 450 times I predicted it. So it is 90% accurate. That is a recall of attack. Okay. That is what recall of attack. Okay. Next we have precision. Precision is like out of all attacks or out of all no attacks predicted. Okay. What it means? Out of all no attacks predicted. Okay. Out of all no attacks. What is no attacks predicted? 450. How many times it is correct? So it is correct for 400 times out of 450 times. Right. So out of no attack predicted, 450 times no attack was predicted. Okay. When 450 times no attack was predicted, 400 times it was actually no attack. So this is a precision value. You can calculate. Right. Same way precision for attack. What is a precision for attack? It is the out of total predicted attack. What is the total predicted attack? 550. Okay. Out of total predicted attack, how many actual attack happened? So 450. This is what precision. 450 upon 550. So precision is calculated vertically. That means out of all benzene attack predicted, okay, all the time it was a benzene attack. So that's why it is 100%. One is the precision is poor for this guy. DOS golden eye, because your sample size was also very lesser. Rest everything is good, right? Then we have a F1 score. F1 score is basically the combination of recall and precision. Okay, F1 score is what? Is a combination of F1 score. Formula. It is a combination of precision and recall. Okay, collectively, if I want to evaluate, we can use F1 score. Right? And then we have the ROC AUC value. So this is area under curve. So area under curve is basically created between true positive rate and false positive rate. Right? So if the area is higher, that is a more balanced model. Now there can be a situation where we have an imbalanced data. Right? Like here we have some imbalanced data. Obviously, here we have a imbalanced data. You can see this is 1.9 million. This is 170. So these are good in number. But from here, the sample size is very less. Okay, this is called imbalance. That means if I will make a model to learn, what happened? Model will learn more about these guys. Okay, and model will not learn much about these things. So what can I do? I can just combine them into a single category. I can combine them into a single category. That category can be other type of attack. Isn't it? So that is what we can do. In near load traffic, attacks are rare compared to normal traffic. Always, because attacks don't happen daily. Attacks will, you can, that's why you can say normal is maximum. Normal is 1.9 million, but attacks were lesser. Right. So always you get the, most of the time you get the biased data. Right. So if you have biased data, we use the resampling, like oversampling we do through the synthetic minority oversampling technique estimation. Undersampling we do. Undersampling is remove some of the samples from here. Okay. Because I have to identify the attack with higher accuracy. Okay. I want to identify the attack with higher accuracy. I want higher true positives. So I will remove the normal data. I just remove some data from here. Okay. The normal case data I'll just decrease. That is called undersampling. Okay. Or I can do a smart oversampling. That means these kind of information we try to increase through the oversampling technique. We can, kind of tune the class weights. Okay. That means we'll give the higher weight, default weight to the minority class. During the machine learning, we'll give the higher weight value to the minority class compared to majority class. Okay. We'll just work on the focus on model normal behavior. Ensemble methods are there like bagging and boosting. We can just adjust the threshold to decide the attack. Okay. Suppose threshold value we are setting at 0.5, we can make it 0.3. Right. Because data is imbalanced. So multiple techniques are there. Common pitfalls in ML for IDS: use IP as a direct feature. Raw IP are high cardinality, like leak identification. Temporal leakage are there. Dataset bias. Already I told you dataset bias will be there. Feature explosion. That means too many features. You can see over here. We have how many features are there. If I'll show you, you can see these many features are there. This is called feature explosion. Sometimes we just kind of see how many features we have total. Let me check. Data dot set. It's 79 features. Okay. 70 out of that we have a label also there. So you can consider 77 features. So it's a huge number of features. So in such case, we can use principal component analysis, right? For the feature reduction and all. Right. Now, practical deployment consideration. Well, performance optimization we have to do. Stateful aggression we have to maintain, right? And we should be capable of explaining our model, right? Now let's go ahead for the, okay. So now let's go ahead for the hands-on. These are the hands-on explanation. So for the hands-on, what I'm doing, I'm using this particular data, right? Now this is a data which is basically present. If you see, this is a paraquet data. Paraquet. Okay, paraquet is just a kind of you may have used paraquet or may not. I'm not sure. Paraquet is basically your zip folder. It is just like a zip data. Okay, zip data. It is zipped. The data is zipped over here, right? Paraquet. So what you have to do, you have to just download it. Like first click here. From here you can download. Then click on the next. Then download from here. This is a download button. Or you can download everything from here. Okay. Third one, download from here. Fourth one, download from here. So it's like I already downloaded it. Okay. And I kept this downloaded and then I extracted. Okay. After download, you have to unzip it. I'll show you. One example I'll show you. Let's say this is something. I'll just try to have the smaller one. Okay, let's say I download it, right? So I downloaded it. Now once it is downloaded, if you see, it is a zip folder. Right? It is zip, right? So I'll go to the location where it is being downloaded. Okay. And I will unzip it. Extract all. So when I extract all, you can see this is my data. How to read it, I'll tell you. Right. So download, extract each of the folder I downloaded and extracted. Right. And I stored it into a folder which is called Intrusion. Right. This is what I did. That means I have downloaded the complete data and stored it over here. After unzip, okay, not directly. After unzipping it, right? Download, unzip, store, download, unzip, store, right? Or you can directly download it from here and unzip it. All right. Next, I have to use it for the machine learning purpose. Right. So what I do, I'll just have my Jupyter notebook or any environment where you want to code. Already I had given the code, but I'll just try to tell you the step-by-step process. Okay. So over here, what we require, we have to first import the libraries. Okay. So the libraries that I'll import is pandas. This is a library for handling the data file. OS for accessing the directory, because all the files are within a directory. So I want to access that directory to access my data file. Right. Then from sklearn, that is a scikit-learn dot model selection import train test split. What this guy do? This guy will be used to split your data for the training and test portion, because everything you can't use for the training. After the training, we also need to understand how is it behaving on a data which is not used in training. Right? So it's not like that I get 100 sample, I'll use all 100 sample for the training. For the training, I'll just use 80 samples. And then once we have the trained model, I try to understand how my trained model is behaving on remaining 20 samples. Okay, on the remaining 20 samples. That's why it is required. Next, from sklearn dot let's say pre-processing, two things I'll import. One, I import label encoder, because everything is not numerical. If something is not numerical, I could convert that into numerical form. If anything which is non-numerical, I need to convert into numerical form. That's why label encoder. And I have to scale down the data. So for that, standard scaler. That will just use your standard deviation to scale down, because all the values are of different magnitude. Each column are having different magnitude. So I want a uniformity. If there is no uniformity, the error optimization will get affected. I want the proper error optimization during the training. Right? That's why I have to scale the data. Apart from error optimization, later on, if I want to explain the features, if I have to explain the features once the model is built, okay, so I have to use coefficient for explaining the features, like how features are important, which feature is important, which feature is less important, which feature is more important. So if I need the coefficient, that coefficient can be better identified if we are using what? Uniform data. Otherwise, based on the magnitude, coefficient will be decided. So I don't want that based on the magnitude coefficient should be decided. I want coefficient should be decided. The coefficient for each feature should be decided based on what? Based on importance of the feature. That's why scaling is important. Next, import the algorithm from sklearn dot linear model. Import logistic regression. Okay, this is something that I want to use. And then I have to evaluate. So from sklearn dot metrics, import classification report. And accuracy score. All right. So this is what I imported. Some error I am doing over here. Here I am missing the import keyword. All right. So let's see, once this will be imported, then what to do. After this, I have to fix the error. All right. Now I have to just print, or I have to just access the data. So let me define the data path. So where my all data exists, my complete data about different attack is existing over here. So I'll just copy this path and paste it over here. This is something where my data exists, right? So I'll make it forward slash so that I can read it. All right. So this is where my data files are existing. But we have multiple files. So I have to create the list of all the paraquat files. Okay. So list of paraquat file, I'll just copy it from here, that the file that I had shared with you, because I don't want to write it once again. It's the same file name. So these are our different file names. Okay. Now we have to access each file one by one. Okay. So what do we do? We'll write a loop for file in paraquat files. Okay. Print os dot path dot join. Join the path. This is your actual path or the directory path with the file name. So this will join the path with the file name. Okay. So these files we have to access one by one. Okay. As these files we have to access one by one, so this can be your file path. Okay. Right. Now I have to just write df is equals to pd dot read paraquat. Okay. P-A-R-Q-U-E-T. What is PD? PD is pandas. Okay. The pandas library that we have. So this is having a good method called read paraquat. Okay. Which can read your file. So just pass over your file path. So this guy will read the file. Now, as it is reading the file one by one, then what to do? I have to just store it into somewhere, because it will read the first file, second file, third file, fourth file, fifth file. So I just defined a data frame variable. Data frames is equals to a blank list, right? And then here I will just add it over there. Okay. So data frames dot append df. So whatever the information you are capturing, you are just storing it. This information we are trying to append it over here. All right. Now, let's say at the end what we get. Everything will be appended. All right. Fine. So let's say data frames. Okay. So now it is trying to access the information. So this is the information it captured. I'll convert this thing into a pandas data frame. I had converted this thing into pandas data frame. Let's see what happened. I'm just trying to convert into pandas data frame. I should store this thing into df, or you can say full df. And then I'll check full df. Uh-oh, getting error. The request in homogeneous shape after one dimension, the detected say wait. Okay. Uh, Data frames. Now it is creating a problem over here, right? Just a minute. Okay, just a minute. Do we have NumPy? Let it be done. I'll do it separately in the separate block. Okay. So I'll try to convert this thing into a NumPy array first. And from the NumPy array, I'll try to convert it to pandas data frame. Let's see if it can be. Okay. So this is a problem. Okay. It is having array as an inhomogeneous shape. Okay. So shape is something which is not regular over here, isn't it? So I can do what? I'll use pd dot concat, okay, data frames. I'll use the concat function, okay, and ignore index. That means I want the index value to be from 0 to 0, 1, 2, 3, 4 because first file will be accessed. So index value will be 0, 1, 2, 3, 5, 6, 7, 8. Next file will be accessed. Again, the index will start from 0. This will also access. Again, the index will start from 0. I don't want that. Right. I want the index to be only 0 to and 1, 2, 3, 5, 6, 7. Suppose up to 10. When it will access the next file, the index should be 11. That's why ignore index is equals to true. Let's see full df. And then we have full df dot save. So it will just concat the things. Right. Now we get the better. Right. So we have 2.3 million data. This is your actual real world data. Right. If I check full df dot head. Okay. So I have the information present over here properly. Right. Now I will check over here that whether there must be some missing values because it was showing over there that irregular shape. That's why it was not converting into data frame. That's why I use concat over here. Concat, I am not using dot data frame because of irregular shape. Right. So if I check full df dot is na dot sum. Okay. So there must be some null values over here. It is not showing this thing because, okay, we can just do it what? Wherever it is, let's say this is null counts. Okay. I want to see where we have the null value. So this is a null counts. Okay. I'll say null counts not equals to 0. So I'll get true or false. Now again, I'll feed null counts over here just to check where we have the true. So there is no null value. That means wherever it is, we don't have the value, they are filled up with 0. That means our job becomes easier over here. Anyway, so if I have to drop the null values and all, what we can do here, null value is not there, but still if I want to drop it, so it's like full df. First, let's say drop duplicate values. Okay. So drop duplicate values, full df dot drop duplicates. Okay. I did something. I should update this thing also. Anyway, so this is like duplicates and then drop null values. So dot drop na. So we're dropping the null values and we're dropping the duplicate values. All right. And once it is done, I'll check the shape. Let's wait for a few seconds so that it can execute. Still we have 2231806. Any safe reduction? 223. Yeah, some safe. It is reduced. It was 223. Sorry, 231. This was the actual data. Now it becomes 223. That means some data is removed, being a duplicate or whatever. Next, we will just find out what information do we have. So these are the features. We have 78 columns. Out of 78 columns, 77 are features, and this is a target. Right. So I'll just take over here full DF. Okay. Dot columns. So it will give me all the columns. Okay. So these are the information we have kind of noted down. Protocol, flow duration, total forward packet, total backward packet. And based on these information, data has been classified as an attack or non-attack. And type of attack that we have over here is this thing. This is a type of attack. Okay. Dot value counts. Okay. Just to count how many. So you can see these are the counts we have. Okay. Now, can we use this data as it is? Yes, you can use this data as it is. But the problem is here, these guys are having very less count compared to these guys. So model will learn quite good about these guys and it will not learn good about these guys. Right. So we will do what? We'll just combine this thing into one single category, which is called other attack. Okay, other type of attack. Right. At least it should tell that other type of attack. If I will use them individually, even attack can't be recognized. Okay. Because the size of data is very small for them compared to these guys. So I should not use them individually. If I use individually, the attacks will also not get recognized. Right. So what do? We can just use over here a simple logic. Full DF. This is label dot apply. I'll apply a function over here, lambda x, and I'll ask it to return x if x exists in, right? If the x, we are just applying this user defined function. I'm creating a user defined function, and this user defined function I'm trying to apply on a label column. Where I'm trying to apply? I'm trying to apply the user defined function on a label column, and logic is very simple. If the value exists in Benign, which is no attack. Let me check the data divided by length of full DF. This guy is having 84% of the data. We have to do something. Anyway, so let's say if X is in benzene, then return as it is. If it is DOS Hulk, then also return as it is. If it is DDoS, then also return as it is. If it is DOS GoldenEye, then also return as it is. Okay. But if it is anything else, that means return X as it is if X belongs to these category. Else return other attack. Other attack, right? That's it. Okay. So now this is a function we are applying it on the target column. So that okay, before doing this, one more thing we should do. we should just convert the target column over here dot str dot lower. Convert everything into the lower case. That would be good so that uniformity can be there. And second, do one thing. Remove any extra spaces. Okay. Done. So now here, if I have converted into lower cases, right? So again, I will just try to check. I have to just fix it. Converted everything into lowercase and extra space is also removed, right? So it should be a small b. It should be a small d and h. This is DDoS. This is DOS GoldenEye. Else other attack. So we are just trying to convert. Now update this thing. Now again, let's try to check the value counts. Okay. So, something is wrong. Is it multiple spaces are there or what? Okay, let me just try to re-execute this thing. Maybe I'm trying to re-execute because this is fine. Okay, so let it be done. Actually, only two categories came. Where are the other categories? So that means something I missed. It will be fixed. Okay, so now what happened? So here I have Benizin. That is fine. DOS Hulk. Is fine. DDoS. Okay. DOS GoldenEye. There I want to keep as it is. Okay. So now we focus on only these 5 categories, right? So now let's say full DF dot head. Okay. So I all are the features. Last one is the target, right? So that is your Y. So Y I have to convert into what? Numerical form, because if I will use it directly, let's say X is equals to full DF dot drop columns is equals to this label. Okay. And then Y is equals to what? Full DF. Only the label part. Okay. And then we have X and Y. Thereafter we can scale it. What I have to scale, or I have to split it. So from is already split library I imported. So X train, comma X test, comma Y train, comma Y test. That would be equals to train test split X comma Y. Okay. So I want the train size should be at least 80%. 0.8. Now we will define we have to scale it down. Okay, because you can see some of the values are in the range of 0 to 1. Okay, some of are having a smaller magnitude, some are having a larger magnitude, right? So I want it to be in a uniform range. So I need a scaling, right? So a scalar is equals to, already we imported a standard scalar. All right. So a scalar dot fit extreme. So this will have the information that how to scale. It will just calculate the required values like a standard deviation and all. And then a scalar dot transform extreme. So this is your scaled value. So extreme scale. Okay. And thereafter X test scale. Okay. So it will just scale it down. Now we have to import the define the model. So let's say I want the logistic regression model. So model log is equals to logistic regression. Already we have imported it. There are few parameters that I'll define over here. That is maximum iteration. By default, maximum iteration is 100, but this is a huge data, so I have to increase it for the training. And then I can fit the data model log dot fit x train comma y train. So when I do it, it will just fit, right, to get trained. So now training process is going on. This will take much time. Once the training is done, we can make the prediction on y train predicted. That would be equals to model log dot predict x train, right, and y test predicted. That would be equals to model log dot predict x test. All right. So let the training be done so that I can make the predictions. And once the predictions will be done, then I will check the performance, that how accurate it is. Isn't it? I've already shared the things with you. That is a code file and other things. Here I am doing it once again just to show you the process. In case if you have anything specific to ask, you can let me know. So this training will take time. You have to see here I am using logistic regression. This will take least time. If I use other things like random forest or some more complicated algorithms are there like bagging, boosting or neural network, it will take much more time. So anyway, let's see with the logistic regression how good is it. If it will not be good, we'll try with others. Here I have not implemented PCA as well. Okay. I just want to check how is it performing on the actual data. And thereafter by applying the PCA, I will compare. Just wait for a minute. almost, these are the things. Like if you're working with a huge data, we face these kind of challenges. Training takes a lot of time. Obviously, because it's a huge data. So it will take time. If you have a GPU capability, it may be a little faster. Almost, it will take few more minutes, few more seconds, I guess. Not, it should not take. That's why, the PCA is required. Because if you are using PCA, you can process, your model can get processed faster. Right? Meanwhile, if you want to execute at your end, you can just try. And if you're finding any difficulty, let me know. Okay. These things you can also try at your end, downloading the data, right? And suppose data accessibility or anything you are finding difficulty, you can let me know. It's taking more than the usual time. Okay, so after this, we don't have to do much. Just make the prediction. And after making the prediction, we can check the accuracy on the training data. So accuracy on training data. Right. So accuracy on the training data is like we have already imported accuracy score. Okay. And I can use over here two things. That is your actual value Y train, comma the predicted value. Okay. So this will be the accuracy on the training data. And next, the accuracy on the test data. This star symbol is showing that it is still processing. So this is Y test and Y test. But only the normal accuracy is not enough. Why? Because we need to understand how is it performing for each category. Because it is a biased data. As it is a biased data, it is very important to understand how is it performing for this guy, and this guy. Right? Because obviously it will perform with high accuracy for benzene. Okay. But benzene is something which is not important. Okay. This is normal condition. This is not attack condition. Right. So now you may be thinking, why are you using this? Because obviously there should be a category called normal to the training. Right. So if suppose 84% data is this one, I need to check whether my model is only predicting normal condition or it is actually predicting these guys as well. Right. That's why classification report is also important. Right. So print classification report on training data. Okay, while making the prediction on the training data. So that's what I can just pick it from here. Okay. And then classification report on the test data. Okay. So here also the process is very simple. We can just take over here the classification report function. Okay. And here I have to feed two things. One is called train and the predicted value. And here the classification report on the test data. All right. Now, once it is done, next what we do, we just try to check whether it is making prediction or not. So we can just take any test data, randomly test a sample. Let's say sample number 100. Okay. And then I can feed it into the model log dot predict, right? So that I can check how is it behaving. Okay, whether this guy is getting predicted something or not. Right. So these are the last few processes that we have to do. Okay. So as of now, training is only going on. I don't know how much time more it will it take. It's approximately 2 million data. So we have to be patience. Meanwhile, if you have anything to ask, let me know. Because this training, I don't know how much time it will take. It may take 10 minutes because last time it was trained little faster. Hmm. Still, it is training. You can see the time it is taking. So when you are doing it, so at the end you will get this kind of result. Okay, in case it is going on. Like that's why I trained it earlier, just for this reason, so that I can show you at least the output. When it will be done, where is my get I had shared with you, right? So yeah, when it will be done, you will get this kind of result. Okay, this is your training is done. This thing I commented it down because random forest classifier, when I was executing, my system get crashed because it's a comparatively huge model, right? But model will be good. It will be a balanced model. It is identifying all the category with high accuracy. Okay, only for this guy, that is the last category, the precision is little lesser, but apart from that, it is fine. Okay, now after this, I had not added the prediction part, right? So if you want, you can just note down this thing, the last line that I have added over here for the prediction, right? So in this way, if you read the continuous behavior of your network, you can easily build up the model, right? Now, after this, if you want PCA, what can you do? You can just import the PCA thing from sklearn dot, but you have to check actually whether PCA is effective or not. Okay, without checking, applying PCA, we need to check the, that is called the variance and all. Okay. So if the variance ratio is not good, PCA can't be implemented. If it is good, then only PCA can be implemented. Yeah. So you can execute the things. This file also I download and upload to you, but I just want that this should be completed. I just want this guy should be completed, but this is not in my hand actually, you know, so I have to also wait. Obviously, it will give me the result, but how much time will it take that I don't know, right? And I can't directly apply the PCA as well, right? Because before applying the PCA, I need to check how raw model is performing. Because suppose if after applying the PCA, my model gets underfit. Okay, if it gets underfit, then how do I know that it is underfit? Okay, so that's why it is important. We have 5 minutes left. Let's see if in next 5 minutes I can get the result. All right, so it is done. That is counting the accuracy. Some, it is saying that total number of iteration limit reached. Okay, so that is fine, no problem. So accuracy is 93%. Overall accuracy is 93%. All right. Classification report. Why it is taking so much time in generating classification report? Oh, it's a 80% of the data. Test will be done more quicker. Train is taking time. Okay. So if you see, we have, this is, as I said, like 97% accurate. Obviously, that is huge number. This is 78% accurate. DDoS, because data sample is lesser. Next, 69% accurate. This is 80% accurate. It is next highest number of sample. So according to the sample size, the accuracy coming down, and this is just 23% accurate, right? So, here same story we have over here, right? And here I'm trying to make the prediction, but I'm getting an error. Why I'm getting error? There, I guess, just a minute. Extreme. Oh no, I have not used a scale data for the training. That's why it was taking so much time. That is a big mistake I did. Actually, here scale data should be used for the training, right? That is very important. But anyway, if I'm making the prediction over here, it is showing me an error. What I do, X test is your what? Is your pandas, right? So dot values, it will convert into numpy array. Now I can take sample number 100. Right. So this sample I have to predict. So it is predicted Benzen. Obviously, it will, most of them will be predicted Benzen. Right. But the problem over here is I have not used the scale data. Here for the training, I should use scale data. I scaled it. That's why it was taking so much time. Right. Then for the prediction also, I should use scale data. This is what you should correct. And for the here also scale data, because I had not used a scale data, that's why it was taking so much of time. Still, it will take time, but comparatively lesser. And accuracy will also be better now. Now this is not as required. I can use X-test scale. Okay, so this is the modification you can do. I'm sharing this file with you, right? And how can you make it better? You can make it better by reducing the sample over here. Just try to reduce the sample over here. Just make it same like 172,000, close to, or you can say 150,000. Okay, just select 150,000 samples from here so that somewhat it can be reduced. The biasing can be reduced. Okay, and thereafter things can be done. Right. So sharing this file with you. I'll just upload at the same section. Data link already I shared. See, the file that I had shared with you earlier was having the higher accuracy because there I had used scale data. Here I am not using, I missed using this case. So here you can see accuracy is very high, right? Because here scale data was used, right? That's why accuracy is very high. But here I missed using I did a scaling, but I missed it. I had not used it. Anyway, that is it for my side. Okay, please go through your things. Okay, and if you find anything which is not, which any doubts or something, you can let me know. How can you let me know? You can let sir know if sir can communicate with me, right? Or you can also connect with me if you want on my LinkedIn, right? So that, in case of any interaction required, you can do it, right? I'll share the profile. So that is it from my side for the day. If everything is fine, we can go, we can close the session for now. Shall I?
Yeah, thank you, sir.
Yeah, yes, sir. Thank you, sir. Shall I close it for
Yeah.
now? Shall I leave it for now?